Right, this video is going to solidify some things a little bit deeper about the multiplication rule and conditional probability. So from the previous video, I copied over the definition of conditional probability. When we write this notation right here, that means the probability that A will occur given that B has already happened. So one way to think about this is if you have B and then not B, and then A and then not A, the probability of A given B is this piece right here, because you're given B has happened, and then that's the probability A given B has happened. Now, one thing that we need to know is when two events are independent, when A and B are independent, then the probability of A and B, you can just multiply those. For example, if you're like flipping a coin and you're assuming each flip, like the probability resets, then you can just do a half times a half times a half, like that probability multiplication is what we can do for independent events. However, when there is a dependent situation or a conditional situation, we can manipulate that equation. So the probability of A and B, you can multiply that probability of B over, and then this is our multiplication rule for conditional probabilities here. And that's what we're going to be using to make sure that we find our probabilities that we're wanting to look at when we have dependency or conditional probabilities. All right, so let's look at this example. It says that 48% of all Californians who are registered voters prefer life in prison without parole over the death penalty if the person convicted first-degree murder. Among Latino Californian registered voters, 55% agree with that statement. And we know that 37.6% of all Californians are Latino. And then it gives us some information about what we're calling our variables. And suppose that one Californian is selected at random. Okay, well, let's go ahead and try to organize this information. So I know that 48% of Californians are going to believe in this life in prison without parole over the death penalty. Okay, now notice that that's what your C is. So let C be Californians who prefer this. And so the probability of C is 0.48. It's given to us. In part B, find the probability of L. Well, L is also given to us. And it doesn't matter if you write this as a percent or a decimal, either is fine. Now we're starting to get into something a little bit more tricky. So now we're looking at some given probabilities. So find the probability of C given L. Well, if I'm given L, then that needs to be my branch here. I'm not going to worry about this until I have to. And the probability that I need to make sure that I look at is this C right here. That's the probability of C given L, right? If you look at our example up here, that is the probability that you went up the L branch and you ended here at the C spot. And so that is 0.55, like that was given to us here in the problem. On part D, this is where we're going to have to use the multiplication rule, because the probability of L and C is the probability of C given L times the probability of L. Now it is also the probability of L given C times the probability of C. However, that's not the given probabilities that we have here, so that one's not really going to help us. So I'm going to multiply that branch together to find the intersection. 0.55 times 0.376 gives me 0.2068. Okay, and so that is one example of how to use a word problem, organize it, and then use the multiplication rule to find this and probability when you have conditional probabilities.